Hello, I'm Ash from Training and Inspection Services, and here I'm going to talk about design verification and design validation. Many people might think that they are the same. They are not. They serve different purpose. Design verification is when you want to verify what you have designed, as the name suggests. So how you do that? Let me give you a simple example. If you want to use a Google map, for example, go from point A to B and it tell you it takes 10 hours. You want to verify whether it takes you 10 hours or not. Now, excluding the traffic you're involved or the break you have to take. Say, for example, you drive down the straightaway. You want to see how many kilometers if it is, say, 1,000 kilometers, and you can do on a motorway, say, 100 kilometers an hour. Yeah, that makes sense. So you're practically verifying that it's really going to take you 10 hours. When you're using a software, you want to know that that software actually giving you the right readings. For the simplest one would be a calculator. If you're adding 2 plus 2, you want to know that it actually gives you 4. Now, all these measuring instruments and softwares, they are all also need to be calibrated. And practically, the software developers kill 2 birds with 1 stone. So they cross-check their software. They put some data in and see whether it's giving them the right output or result. So they not only calibrate this, but at the same time, when you use a software, for example, calculator or a software for designing a pressure vessel or a pump, because it's calibrated, it does 2 things at the same time. It gives you the result, the design calculation. It also verifies that those design calculations are correct because it's calibrated. For design validation, it's more straightforward. Once you design something, you want to know that whether it can actually do what you have designed it for. It's fit for service, it's fit for purpose. So, for example, if you have a pressure vessel, you would do a pressure test, say 1.3 times of maximum allowable working pressure, MAWP. Say if it's 100 bar, the working pressure, then you pressure test at 130 bar. So by pressure testing is successfully 130 bar without any leak or deformation, you're actually demonstrating or showing that what you have designed and built is actually fit for service. If it can withstand 130 bar, obviously it can withstand or tolerate 100 bar of working pressure. The same way goes for valves and storage tanks. Or the pumps or rotating equipment, pumps, compressor, turbines, where you do a performance test or mechanical running test demonstrating that or showing that actually it is doing what it is supposed to do. Say even for welding, you have a WPS, welding procedure specification, where you design the joint, and then you have a PQR, procedure qualification record, that actually validates the WPS. That means you weld a piece within the range of the WPS that you have designed, and you test it. You strength test it, you radiograph it, you strength test it, you bend test it, and then once it demonstrates or you're showing that it's actually that joint has the strength that you have designed it for. So that's the design validation. For more tips, please follow www.inspector-training.com, and I'm Ash from Training and Inspection Services. I appreciate your comments or anything you might have. Thank you.